Welcome back to the shop end of the channel. Believe it or not, this is going to be a machining video, even though I'm showing you a picture of my welder. This is my Hobart Handler 175 Mig Welder. It was really my first big boy welder. I bought this from a good friend of mine, and I used it on many projects, but about 3 years or so ago it started giving me a lot of fits. When I was running solid wire with gas, I was getting a lot of bad welds, and I'm trying to figure out just where the problem is so I can fix it. Well, I'll show you what I mean. I've got the welder hooked up to a tank of C25 gas, which is 75% argon, 25% CO2, and I've got the flow rate set to around 20 CFH. This is a relatively new tank, so it should have plenty of gas in it. I have the gas turned on. I've got a roll of ER70S-6 wire in that I've used in my other welders without any problem. And when I weld on this test plate, it's terrible. It's coming back with all sorts of porosity as if there was no shielding gas whatsoever, or at least very little. You can see here, to bring the camera in a little bit closer, that this weld is just plumb full of wormholes, and this is a key indicator of, no shielding gas, or at least inadequate shielding gas. Well, I've got the side panel of the welder open here, and this hose here, this is what brings the shielding gas down to this aluminum block that's called the gun connector, and that feeds the shielding gas up through the whip up to the torch. And I want to check to see, am I getting gas flow? When I pull the trigger, is gas actually flowing out of this tube and going up into the whip? So with that tube disconnected, I've got the welder on, I'm pulling on the trigger, and I can feel that there's a little air pressure that's hitting up against my thumb, so I know it's doing something. I got a little piece of paper towel here. I'm going to hold this underneath the hose and see when I pull the trigger, does it deflect? And sure enough, it does, and it stays deflected for as long as I'm pulling the trigger. So it's definitely flowing gas through the hose. Well, I think maybe the problem could be somewhere in the gun connector. Maybe there's a leak, a bad O-ring, something. So I want to go ahead and get that out of the machine. So first thing I need to do is go ahead and clip the wire and make sure I don't let it go here before I secure it on the spool, so I don't end up with a big old bird's nest. The excess wire pulled through the whip, I can pull out this thumb screw which holds the end of the whip into this gun connector. Well, and now the whip should come out of the front of the welder. It's a little bit stuck in here right now. I'm not exactly sure where that is coming from, but I think just with a little bit of force I can get it pulled out of there. With the whip out of the gun connector, I can see some clear signs of galvanic corrosion. That gun connector is a piece of cast aluminum, and this end of the whip is copper, and those two metals don't really like to coexist. I want to get this gun connector out of the welder so that I can get a little closer look at the bore that the end of the whip goes into and see if it looks as bad as the copper counterpart. Sure enough, looking at the inside of the bore, it's an absolute mess. It is pitted, pitted, pitted. There is no surprise whatsoever that I'm getting air leaks into this, and it is contaminating my shielding gas. Unfortunately, this part is obsolete. It is no longer available. I searched and searched and searched, and it doesn't exist. So we get to make a new one. I've got this big chunk of scrap aluminum that will be more than adequate for this part, and I'm going to go ahead and put a little bluing on here so I can cut or scribe some layout lines and shrink this up a bit on the bandsaw. Well, I got this rough cut on the bandsaw, so I can start here. And I think the first thing that I want to do is get this squared up and get the overall size correct. And we'll do that over on the shaper. I haven't used that in a while, so let's go use the shaper. Well, to square up this piece, I'm using a tried and true method that I think I learned this from Tom's Techniques, which is a YouTube channel. I don't think he's published a video in years, but all of the stuff that he's got on there still applies. I've taken what I think is at least reasonably the closest to flat side, and I have sat it to the fixed jaw underneath a parallel, just a single parallel. And then the opposite side against the moving jaw has a piece of copper wire wedged in there just to put some pressure on it. So this is keeping that one sort of square piece up against the fixed jaw, and now I'm machining the top of it to be square-ish to it. Well, after a quick deburr here with a file just to get those edges, those raised edges down, we'll go ahead and put it back into the vise on a slightly shorter parallel this time. And now I'm going to take that freshly machined side, I'm going to put it up against the fixed jaw, and everything else will remain the same. Now I can machine this top face, and it should be square to the face that's up against the fixed jaw right now. Well, next I'm going to take that face I just machined. I'm going to put it up against the fixed jaw. And now I'm setting this on two parallels because I now have two square faces that are square to each other. So I'll place the original face on two parallels. I'm still going to use the copper wire because this opposite face is still rough, and I want to make sure that I take up any irregularities by using that little piece of copper. I'm going to try to seat this down so that it sits on the parallels securely and that the parallels don't move. That'll tell me that that bottom face is seated flat on the bottom of the vise and that the face up against the fixed jaw is square to it. Well, with that third face now machined and square to the other, I can now rotate it again another 90 degrees. I no longer need that copper wire because the three faces that are now down into the vise should all be square and parallel with each other. Machining this last surface should make this side parallel to the bottom and then square to the left and the right, as at least as I'm looking at this head on, looking at the shaper. Well, to square the two ends is something I've actually never done on the shaper. I've usually taken this over to the milling machine, but this time I wanted to give it a shot. So I've got everything sort of reconfigured here and the shaper cutting on the downstroke here. I have to manually feed it down because there is no power down feed here on this little shaper, but as the ram comes forward, when it's at its forward most, I'm just reaching up and just kind of turning that dial so it drops at about 0.010 of an inch. With one end machined, I need to now concentrate on the opposite end, and to get me a little more accurate on the overall dimension here, I'm putting a dial indicator on the side of the table, and then as I move the table over, I'll know exactly how far I am moving the cutter, how much I'm going to end up taking off of the end of this piece. I need to take off about another 54 thousandths to get me to the dimension that I'm looking for. While the shaper work is done, this is two dimension and it is mostly square. I think that mill vise just really isn't all that great. I think it's got some problems that I might try to fix if I ever get around to rebuilding that machine. But for this particular project, I don't need super precision, but it would be nice to get that working. Now that this thing is to size, overall dimension, I need to go ahead and use the Bridgeport to finish this off. But I'm going to use some blue dicam here to scribe some anti-bozo lines first before I do that. I'll do that off camera. Well, I did take some dimensions off of the original and I drew it up in Fusion 360. So I am working off a set of plans with dimensions. But having these scribe lines on here certainly makes things a little bit, I guess, more preventative of making some kind of a stupid mistake. I really don't want to have to make this part more than once. Well, my first operation is going to be milling the tang here that is where the power lead for the gun attaches to this connector. This is the actual welding current, where the welding current meets the connector, which ends up in the whip to the torch. I'll use an edge finder here to find the front and left edges. All my dimensions here for this first operation are just coming from there. I have a 2-flute 9/16 inch end mill here in an RA collet, and I'm using a piece of paper here to set a approximate Z height. I need to mill down about 12.7 millimeters, about 19 millimeters from the left edge. Well, I've removed the end mill and I've got my drill chuck now in the mill with a spotting drill. I'm going to spot and then drill the tap size for a 1/4-20 screw. I'll finish this side up here with the quick chamfer, and once I take it out of the vise, I'll go ahead and manually chamfer the opposite side. Well, I have this reset up in the vise so I can finish machining off the remainder of the material that will end up forming the tang. I'm going to swap out the end mill for the drill chuck again. On a side note, I really do like having this power drawbar in the mill. It has really been a game changer in using a mill. I'll put a link to the playlist of the one that I made. If you don't have one on your mill, I highly recommend that you get one. Anyway, I've got the drill chuck in here, lining up to drill and thread another hole. This is the hole where that hose barb will enter to allow the shielding gas into the gun connector. I'm going to start with a 1/8 inch drill bit. I'm going to drill down about an inch into the block, and that should be deep enough to intersect with the bore I'll be creating later, where the end of the MIG gun whip actually attaches here. Well, that 1/8 hole is going to be at the bottom of this. At the top of it is going to be threaded for M6 by 1. So I've got a number 9 drill in here, and we'll drill down about 13 millimeters deep. It is interesting to note that this part does have a number of imperial features as well as metric features. I plan on just reusing the plastic hose barb that was on the original gun connector, and it was threaded M61, so I figure why bother changing that. I'll just reuse the part I already have. I doubt I'm unique amongst hobby novice machinists in which you struggle trying to determine an appropriate order of operations, and this is no different. I've actually put a lot of thought into what features I should mill first, second, and so on. So right now I've got this reset up in the vise on the front face, I'm calling it, and I need to drill and tap a hole for that thumb screw that secures the copper end of the MIG gun into this gun connector. And I will drill this down about halfway into the part and then tap it for a 1/4 20. Well, I have this part now rotated around again. I've got a couple of features to machine here. The first of which is going to be a 12 millimeter reamed bore all the way through this face. Well, the next feature to machine is to remove all of this material here. This will be 25.5 millimeters deep and 25.5 millimeters wide. Well, everything seems to be going so far so good. I'm pretty happy up to this point. The next thing I need to do is drill a clearance hole for the nut and bolt that attaches this into the welder. And while I'm here, I might as well go ahead and chamfer that 12mm bore since I forgot to do it before. Well, we're getting down to the last major feature to machine, and that's this hook feature that hooks over a tab inside the welder by the drive rollers. And I think it's just there for alignment purposes so that that 12mm bore lines up with the drive rollers for where the wire feeds out. The first step is to go ahead and machine about 3mm off of this surface, about 56mm from the right edge. Well, to machine the actual hook here, I've got a 1/8 inch key seat cutter, and this should give me what I need to machine that hook. And I realized while I was editing this video that I actually got a little bit lucky, because I should have gone and cut a little bit more off of the surface of this before machining the little hook. That hook ended up a little bit thin, and I really wasn't sure why it ended up so thin. But as I was doing these voiceovers here, I realized that that 3mm that I went down wasn't deep enough, and it really should have gone down about 3.5 to 4mm. I got lucky because I probably blew the dimension to begin with. But this is the last major operation, and we should be able to clean it up and see if it solves the problem. Well, and here's the finished part. It's all cleaned up and deburred. I was going to take it over to the Scotch-Brite wheel, but I've moved my buffer to a spot in the shop that takes it a little bit further away from the rotary phase converter, so I don't have an extension cord on it yet. Once I do, it'll make it a little easier to use the buffer, but we'll attach the barb here for the gas hose, and we can go ahead and get it installed in the welder. I got the gas hose connected to that original plastic barb, and now I'm just going to connect the power lead up to the top tang on the gun connector, and then we can remount it onto the front of the drive rollers. Like this. Now, as you saw from the opening video, there was some galvanic corrosion on the end of the MIG torch. I don't think that's going to be a major issue here. I was able to replace the O-rings, and that should be all that I need to get a good seal but if I have to replace the torch, I will, but I don't think I'm going to need to. Well, with everything back together, let's go ahead and give this a quick try. And although that sounds a little weird, I think it's a wire feed speed issue. I don't see any porosity in the weld. Let me adjust my wire feed speed and see if that resolves this. Oh, not yet. I definitely think that's a wire feed speed issue. Let me do another adjustment. Well, the bonus is here, there's no porosity in that weld, although, again, I think I need to make an adjustment to the wire feed speed. This piece of plate is probably a little bit thicker than this welder is normally capable of, so I'm going to have to finagle with the settings a little bit to get it to weld at least reasonably well. This is a little bit better. Well, still not perfect, but we're getting there. But the most important thing is that there is zero porosity here. I am getting good shielding on this weld. Yeah, that's a good sounding weld and it looks good. I think I got the settings where I want them. Well, I don't think I can be any happier. This thing is welding great. There is no porosity in it. This thing's been relegated to flux core wire for the past few years. I didn't think I was ever going to be able to run solid wire through it again, especially not being able to ever find that part anywhere. And I tried everywhere to find that part. Well, that's going to be it for this video. If you like it, give it a thumbs up. Subscribe if you're not a subscriber. Thanks for watching, and we'll see you on the next one.
Yeah. That's fixed. On to the next job.